Hello and welcome to this three-part series on predicting the future with machine learning. In part 2, Eric Boyd from responsiveX shows you how to experiment with your data in Azure Machine Learning.
A couple of important things related specifically to Azure Machine Learning. And you'll see this in action. I'll show you this here in just a minute. But Azure Machine Learning is a service within Azure. There are kind of two known portals for Azure. There's what we refer to as the old portal or the classic Azure portal, and there's the new portal. Microsoft is steering us towards the new portal. It has a lot of new capabilities. It's a really nice new portal, but Azure Machine Learning today is accessed from the old portal. So that's important to note, and you'll see that in action. Azure Machine Learning also has its own web-based kind of IDE or development environment. It's called Azure Machine Learning Studio, and you'll see that in action today as well. So you don't need to download or install anything. It's all in the browser. You can build your models without installing anything and just using the Azure Machine Learning development environment. So this is the overall kind of visual. You'll see this menu on the left-hand side of the Azure Machine Learning Studio, but I wanted to break this out before we got into it of what all of these things are. We'll spend most of our time today in experiments. And experiments is where you build, just like it sounds, an experiment and ultimately create a model. So we're building a pipeline of machine learning algorithms, and that's ultimately driving our model. There's also a way to group these machine learning assets together into projects. That's in preview, but it is a new capability that we can take maybe a bunch of machine learning experiments and models and that sort of thing and group them together into projects. In the next webinar, we'll look at web services, and that's a way for us to expose these machine learning trained models as a web API so we can tap into them from our applications, whether that's a mobile app or a web app or whatever that may be. We can use and operationalize that model. There are notebooks, so if you are a Python data scientist and you write lots of Python algorithms, you can bring in your Python Jupyter notebooks right into machine learning and use those as your kind of scripts and algorithms. There's also data sets where we upload data that we use for experiments. So if we had a CSV or some kind of data that we wanted to bring into machine learning that we weren't going to read interactively from a live data source, then we could upload that into data sets. And you'll see inside data sets, we'll use that a little bit today as well. You can see that there's predefined data sets for us to get started and kind of kick the tires and sample with. And then trained models is where we take our experiments that we've created and convert them into a model that we can then reuse and pass in new data to. And so that's what trained models is all about. And then settings is, like it sounds, where we manage some things about Azure Machine Learning, so users, authentication tokens, that sort of thing. So we're going to follow some basic steps. We're going to create an experiment. We're going to create a few, but we're going to go through some process of reading in some data. We're going to clean that data. We're going to select important columns from that data, and we're going to do some supervised learning. So we're going to split that data up and use some of that for training and some of that for kind of doing some cross validation of the data and ensuring that our model is not overfit or it's going to work statistically across other data besides just the data that we have. And then we're going to route that into an algorithm. We're going to choose an algorithm from the large collection of algorithms that we have to choose from and bring that in and create a model from our data in our experiment. So that's our process. With that, I'm going to break out into a browser, and this is the new Azure portal. I mentioned that there's a new portal and an old portal. If you go to azure.com, you can create an Azure account or a subscription. So here up in the upper right-hand corner, there's a link that's free account. You can create a free 30-day trial or $200, whichever one you run into first. And so this will allow you to experiment with Azure all up. And so this isn't just limited to machine learning. Machine learning is one of the services that you can use, but this would be all of Azure. So if you don't have an Azure subscription, this is one way to get started. Another way to get started is through MSDN. So if you have a Visual Studio MSDN subscription, you also can get up to $150 a month of free Azure services that you can use for testing and doing some development. So depending on your level of MSDN, Visual Studio and MSDN, you can get up to $150 a month every month to use of Azure. So those are the ways to get started. Once you do that, then you'll come into the Azure Portal, and the Azure Portal is where all of your resources are, where you manage everything. I mentioned this portal, if we go look at our resources, we don't have any machine learning resources here. So if we go hit Browse and look for machine learning, you'll see Machine Learning Workspace listed here. But what you see is this little icon, and it's different than the other services. There are a few of these services that have this icon, but most of them don't. And the reason for that is that icon means this is in the old portal. It hasn't been brought into the new portal yet. And so by clicking this, it's going to take us over to the old portal. So I already have that up. If we clicked that, it would take us right over here to the Azure Machine Learning service in the old portal. And so this is the old portal. You'll see on the left-hand side, we have a whole list of services to choose from, and there's Azure Machine Learning. So I've already selected Azure Machine Learning, and you'll see we have an Azure Machine Learning workspace already. So I'm going to click into this. This is our Azure Machine Learning workspace. We can do some things. We can configure some things here, access controls, that sort of thing. But what I really want to do is open this in Azure Machine Learning Studio. So if I click this link at the very bottom, or over here on the right-hand side where it says Sign In to Machine Learning Studio, this will take us into Azure Machine Learning Studio. I've already done that, so this is the Azure Machine Learning Studio, and this is that menu down the left-hand side that we talked about just a little bit ago. Now we're going to focus our attention right here on experiments. Now I already have some pre-built experiments, just in case as we demo things don't work out well, but I'm going to go through and create a brand new experiment, and we're going to give that a shot. Before we do that, I'm going to click on datasets, and you'll see that there are no datasets that I've uploaded, but under datasets, there are my datasets and sample datasets. And one of the things that you'll see here is a whole list of sample datasets that are available for us. And these are just a way to get started and kind of kick the tires and play with Azure Machine Learning without having to upload or worry about getting your data into Azure Machine Learning, because that can sometimes be a complicated, lengthy process. In fact, wrangling data is probably where we spend 75–80% of our time in machine learning experiments. And so having that kind of taken out for us, already out of the way, with some sample data sets for us to just get started and kick the tires is really nice. And a lot of these sample data sets came from the UC Irvine Machine Learning Data Repository. And so you can find that at archive.ics.uci.edu/ml. But that's a great set of kind of sample data sets that you can get started with that are already, for the most part, prepared for us to work with in Azure Machine Learning or in a machine learning experiment. So with that, I'm going to browse back over to Machine Learning Experiments, and in the lower left-hand corner, you'll see this New button. This is going to allow me to create a new experiment. Now you'll see that there are a number of sample experiments already created here. And so if you wanted to learn like how to do a neural network, here are some sample neural network experiments already for you that you can just kind of open up and see inside of the machine learning experiment and play with. If it's something like multiple classifications, there's an experiment for that. There's experiments for pretty much everything, kind of every scenario that you might want to play with. So recommendation engines, all that sort of stuff. So this is a good way to get started and just see how to put together one of these experiments and models. In our case, I'm just going to going to create a blank one. And we're going to call this Webinar Auto Price Prediction. And I'm going to name this Draft. I'm going to save this, but right now it won't let me save because there's nothing in here. So the first thing I'm going to do is get data into this experiment. Now I'm going to use a sample data set, and I'm going to use this automobile price data. So I'm going to click this automobile price data set and drag it right onto the canvas. And so there's our first kind of module in our machine learning experiment, just reading in this automobile price data. I should be able to save it. Nope, I cannot save it yet. So I'm going to now clean the data. So I mentioned earlier that I need to kind of prepare the data for our machine learning experiment. And so the next thing I'm going to do is select some columns and start to clean this data. So here's a select columns in data set. If we look at the data, let's do that first. You'll see that this is a nice way in Azure Machine Learning to visualize the data that we have in our data set. So you'll see this is a pretty small data set. We have 205 rows, 26 columns. We can see statistics over this data. So if I wanted to look at fuel type, for example, there are 2 different values in fuel type, and that's the distribution. I have gas and diesel fuel engines. If I wanted to see makes, for example, here are the stats, the basic kind of statistics about this. There's 22 values, and none of them are missing. That's very important because we can't have missing values in our model. And that's the distribution across all of the makes we have. So it's a really nice way to visualize the data statistically before we get started. But one of the things that you'll notice is this normalized losses column has 41 missing values. And that is going to be problematic for our model to have missing values. Now what we could do is clean that column and just put zeros in for the missing values. But because it's statistically so many, this case is about 20%, but what we would recommend if it's over 40% in general, unless it's it's really important for your model, we would dump that column. In this case, it's just 20%, but we're going to do the same thing and dump that column. So we have our select columns and data set. I'm going to drag from that balloon down to the select columns and data set balloon. I'm going to launch the column selector, and I am going to get all columns except for the normalized losses column. So now I should be able to run this. We can look at the data that comes out of the select columns and data set, and you'll see we have everything except for, hopefully, everything except for normalized losses. So we're starting to clean that data. Now we have missing data in this still. So if we come over and look at the data again, kind of scroll through, we should see that some of these columns have some missing data. There we go. So there's missing data. There's some missing data. And we can't have that in our model. In this case, we've decided that that missing data is not important for our model. So we're going to drag this clean missing data module over. We're going to drag from this balloon down to this one. And we are going to remove entire rows where there's data missing. So here, if we look at the data, we should have 205 rows at this point. I'm going to run this through. And then I'm going to look at our cleaned data. And you'll see we pared that back. We now only have 193 rows because we got rid of those rows that had missing data. And so we scroll through here now, we should see those blanks all gone. All right, so I'm going to save this. And now I want to select the things we care about for our model. And so we excluded one of the columns earlier, and there's ways for us to determine the correlation across these columns and what's important for our model. In my case right now, I'm just going to manually select the columns. So I'm going to choose this. I'm going to drag from here to here. And I'm going to select columns out of our data set that we think are relevant to the model. So make, we think is relevant. If we select some other characteristics, let's take body style, wheelbase, engine size, horsepower, RPMs, highway MPG, and price. So we have 8 columns selected. Now price is what we're going to predict. So that's important for us to have in our model. So now if we run this and visualize the data coming out, instead of the 25-ish columns that we had, we should have these 8 columns. So let's take a look. And there are our 8 columns. Still yet 193 rows. So now I want to split this data because I want to have a training set of data and a set of data to validate the model so I don't overfit the model. So I'm going to drag a split data module onto the canvas, and I'm going to tell it I want to split by 75-25. So there's my split. I now want to do a linear regression. That's the algorithm I'm going to use here because it's a regression scenario where I'm predicting an exact numerical value. So regression, there's my linear regression algorithm. I'm going to drag that over onto the canvas. So I need to get this data into this module, and to do that, I'm going to drag a train model module over onto my canvas. And so this is what's going to do the training. So I'm going to grab data from here. This is my data set going into train model, and this is my algorithm going into the train model module. Now at this point, I could run this, but it needs a value or a column to predict. And so we're going to predict price. So on train module or train model, I select the column that I want to predict, and in this case it's price. Hit OK. So now my model is ready to, my experiment's ready to run. So it's running through. It's doing the training here. And I now have a trained model. And so here's all of the factors of that model, how it weighted everything in the linear regression. But how do I know what the output was? How do I know what the success was of this model? So I now want to bring a score model module over and connect it to the trained model and the other side of that split data. So that's going to let me do some cross-validation of the model to ensure that what it did was statistically okay. It's going to give me good results on new data. So I'm going to run this. And while it should run through pretty quickly. There we go. So now if we look at the data from the scored model, you can see here are our predictions, and you can see predictions coming out of this model. So those are the values that we predicted, and the training of that basically. And so we can click on this model and column, the scored labels, which is the price that we predicted, and you can see the price on the left-hand side, how those correlate. So you'll see we predicted pretty well overall in this model, and you can see the min, max, and the standard deviation of our predictions as well in this column as well. But what we really want to do is know how well we statistically predicted that column. So that's the values that came out of our model. And we want to evaluate that model and see how well it performed statistically. And so we're going to drag this evaluate model module over onto our canvas. I'm going to wire it up, run this again. And now I'm going to visualize the results, and we can see a couple of stats that are important to us about the performance of our model. Now the first four, so the third and the fourth option, the relative absolute error and the relative squared error, the closer to zero, the better the model. And so we can see here that we did pretty good on those. And you can see in the top two, this is the mean absolute error. So the difference between our predictions and the real values, that is the average of those, the mean of those. If we go down to the coefficient of determination, the closer to 1 that we get, the better off the model performs. And so we have a pretty good model here at 91% basically. So that's performing pretty well for us. So we're not trying to get to 100% sort of. I mean, that would be ideal if we get to 100% accuracy and precision on predictions. But if we can do better than a coin flip, we're doing pretty well. And so this is telling us that we're doing better than a coin flip with this model. So this is a model doing a linear regression. In the next webinar, we'll take this model and we will turn it into a web service so that we can call from other applications, from things like Excel. We'll see some things maybe with Power BI. But this is a pretty simple linear regression. I want to show you a couple of other examples, a couple of things that came up in the last webinar. This is a targeted marketing model. So this is based on the AdventureWorks data. Now you'll see at the very top, we're not bringing in a CSV or a data set that's been uploaded. Instead, we're reading data from a live data source. And so this is reading from an Azure SQL database, and we have the AdventureWorks data warehouse data in that live database. If I open up the query, you'll see that we're querying this view that's a V target mail view. And what it's showing us here is if someone bought a bike and we sent them mail, that sort of thing. So we're trying to decide whether it's useful to, we're segmenting our marketing list basically and deciding whether it's useful to send them mail, whether that will encourage a buy. So you'll see here we've done similar things. We're cleaning up our data. We're selecting columns that are relevant. We're splitting it. In this case, we are also running two different models. So we've talked about ensemble models. We can certainly do this, but what we're trying to do is take two different algorithms and determine which algorithm is more effective. And so in both cases, we are doing a classification algorithm, a binary sort of classification algorithm, that is whether it's a bike buyer or not. And so we have a boosted decision tree, which is an ensemble model in and of itself, and then a two-class Bayes point machine learning model as well, or algorithm as well. I've already run this model, so I visualize this. What we'll see is the performance of those two. So the blue line is the ensemble model, the two-class boosted decision tree. The red line is the two-class Bayes point machine. And what we're looking for in this curve, again, as close to 1 as we can get, the better the performance of the model. And so you'll see this blue line, the curve is much higher than the red line. The line from 0, 0 to 1, 1 that's straight across would be a 50-50 sort of accuracy. And so that's kind of a coin flip in this case. It's a two-class, it's a binary sort of model. So being below that line would be really bad for our model, but being on that line isn't really much better than a random sort of coin flip. So the red one outperforms that. The one on the right outperforms that. But the ensemble boosted decision tree outperforms that significantly better. And so we can see that from this evaluating two sets of algorithms side by side over the same data, we can see which one is going to perform better for our scenario. And in this case, it's the one on the left-hand side that we would choose for our model. So that's one example of that. And then also in the experiments, I have a recommendations engine that's taking the same sort of thing, data from AdventureWorks, reading it in, and we're making product recommendations to customers. And so these are the recommendations based on ratings that we have of products for customers. So if you were an e-commerce retailer and you wanted to make suggestions and product recommendations to customers, you might build a recommendations engine. Or if you wanted, there's all sorts of scenarios where you would want to build a recommendations engine, but that would be a great sort of textbook canonical example. So all of those things are very simple to do inside of the context of Azure Machine Learning.
Thank you for watching part 2 of this series. To catch the other parts, you can visit this URL. To learn how responsiveX can help you get started with machine learning, visit this link to explore an engagement.